I'm holding probably the most amazing piece of metal that you've seen in any of our videos. This is the original mirror from Isaac Newton's first telescope, and this is his actual first telescope that he made. You can see behind it is the drawings that he made and the description he wrote in Latin of this telescope. So this telescope has been with the Royal Society since 1688. There was a bit of interruption where it was went to an instrument maker, so there may be some later editions, but there's absolutely no doubt that this mirror is the original mirror. If I was a physicist, I'd be telling you about the wonders of this telescope and the advantage of using a mirror over lenses so you get better images. But I'm going to tell you about the metal of the mirror. And the mirror is made from a metal that is called speculum. Speculum is not an element, it's an alloy, a mixture of metals. And it's a mixture of tin and copper. Now you can see the problem straight away if you're making a mirror to look at stars and things is that copper is coloured, it's red or reddish colour. And for a really good mirror you need to have it absolutely colourless so that you see the actual colours of whatever is in space. The moon looks the right colour. It just happens that if you mix 2 parts of copper with 1 part of tin and just put in a little amount of arsenic, and obviously I'm not in a lab so I haven't got any arsenic here, you can get a metal which has been known for perhaps a couple of thousand years called speculum, which gives you a really nice mirror finish. Speculum is the Latin word for a mirror.
That's not a very good mirror.
Well, when it was first made, it will have been polished and it would have been really good. And you can still see the traces of its polishing. So what's amazing about this is how heavy the metal is. Copper is quite a dense metal, and so is tin. So this is much heavier than the modern mirrors that you would have, which are made out of aluminium, which is very light. And this mirror fits in the back here, so the light comes into there, onto the mirror and back again, and here is the eyepiece. So you look in there. And if you look at Isaac Newton's drawing here, you can see there's a picture of his eye. I don't know whether this is Isaac Newton's eye or somebody else's. So you can see here's a large ball, which is quite a clever mount that allows you to turn the telescope in whatever direction you want. And I was quite mystified because there's a little crown down here. And I wondered why on earth in a telescope you should need a crown. And our librarian explained to me that Newton tested his telescope by looking at some architectural feature in Cambridge on another building. And here is an indication that he drew to show the magnification, how much bigger the image was. And this is what it looked like to the naked eye, and here's what it looked like through his telescope. So it really worked. I just think it's extraordinary that I should be touching something that Isaac Newton should have made himself. But to come back to the chemistry, it is really very interesting that one of the key features of this telescope was having the right material to make the mirror, because if you couldn't make the mirror, nothing else was important. And so right at the heart of this fundamental development in physics was a bit of chemistry. It turns out that you have to be quite clever in making this alloy, because if you put too much copper, then it's red. And surprisingly, if you put too much tin, it's a bit blue. So there's a rather nice sweet spot, which, depending how much arsenic you put in, gives you just the right mixture so that the surface reflects colours faithfully and doesn't absorb anywhere in the visible spectrum. I'm not a metallurgist, but very often quite small amounts of added material can affect the way that metals crystallize, and the way that it crystallizes then affects its surface properties and hence affects the way that it reflects light.